Alright, so here we are back on tissues. This is the second of the three short videos on tissues. We previously discussed the epithelia, and now we're going to look at the connective tissue, which makes sense because it's the connective tissue which actually attaches the epithelia down onto the rest of the body. So in connective tissue, as the term suggests, it's a connecting tissue type. However, not all connective tissue actually does this as its main job, so we can break them into four main categories. So on the board behind me, we have connective tissue proper, cartilage, bone, and blood. Blood being the only liquid connective tissue, only liquid tissue, indeed. So let's first of all think about the properties of connective tissue before we get into the differences between these four. So the three main properties that we have in connective tissue is vascularization. Remember I said in epithelia, the epithelia is avascular, meaning it doesn't have a direct blood supply. But the connective tissue that sits right underneath it does have a vascular supply or blood supply. Now the level of that vascularization is variable depending on the tissue, and the connective tissue loose, such as fat cells, adipose, areola, reticular, they're very highly vascular, and therefore they can reproduce themselves very, very quickly because of that high vascularization. The more, generally speaking, in anatomy and physiology, the more blood that you have going somewhere, the faster it can turn over because it's getting lots and lots of nutrients to do that with. So vascularization is variable in these tissue types, and we'll talk about them as we go through them, such as tendons, ligaments, which are very, very tightly packed fibers. They're actually quite low in their blood supply, and even lower is the cartilage, which is almost like the epithelia in the sense that it doesn't have the direct blood supply. Instead, it feeds off the cavities, etc., and the fluid, the nutrient being filtered out of the blood into the fluid cavity around the cartilage, and it gets it mostly from there and from cells lying underneath it. So as I said, vascularization is variable. Connective tissue proper, this first of the four groups, is the only one of the four that actually physically connects here to here, for example, like that. It's connecting something, which is why it's called proper, because that's its actual job. So why on earth do we have three other categories in this tissue type? Well, it's because they come from the same developmental origin, meaning that embryologically they actually come from the same cell types, and so they are actually a lot in common, even though the cartilage, the bone, and the blood don't technically connect things in the sense of, if you had a rope, you tie it on one side, you tie it on the other, and now you've got a connection. However, they come from the same developmental origin, so they stay within the connective tissues. Now finally, and very, very importantly with the connective tissues, the production of a matrix. What on earth is that? Well, for people of my age, matrix immediately makes you think of Neo and lots of science fiction action, because that was a very popular trilogy about 20 odd years ago. However, in anatomy and physiology, it's not nearly quite as exciting as that. So what a matrix is if you have a cell, it's got a little nucleus, the cell produces goo. Around it. So the cell isn't just sitting there in complete perfect isolation, it's actually producing sort of a gooey fluid outside of it. Now in that fluid it can also produce fibres, and there are three types of fibre that we need to know about, and I've got them listed here. So in our matrix, which is being produced inside the cell but then pushed out of the cell, we've got collagen fibres, elastic fibres, and reticular fibres that can all be moved out here as well. Now of course, the more fibre, like rope, you're putting out there, the thicker and thicker the matrix around the cell becomes. So collagen is very, very thick, very, very strong. And if all the collagen fibers are lying like that, just like a rope, it's very, very strong along its axis. Elastic is thinner. But the thing about elastic is it actually has branches. And it's obviously, the term elastic means that it can be pulled out, but then it can return to its original position. So it has branched, it's thinner than collagen, not as strong as collagen, but it has the elastic ability. Now reticular, I always think more as a spider's web, because it's very thin, but it is very heavily branched. And it acts like a spider's web because it creates a net for everything else to stick to. And tissue, organs such as the spleen and the liver are made up very much of this connective tissue, loose reticular, which is all these fibers which just hold all the cells in place. So all three of these cell types can be passed out by the cell into its surrounding area, and that's what's referred to as its matrix. Now, we'll talk about the various matrix that we get from the various connective tissues as appropriate, but that's essentially, what we need to know about it. So, we know that the vascularization is variable depending on the actual given tissue. We'll talk about that. Same developmental origin explains why we have cartilage, bone, and blood in the connective tissues, because they're not properly connecting things, but they come from the same origin. And then we also now understand that the cell produces a matrix around it. And that matrix can consist of goo, but as well as that it can have fibers, collagen, elastic, and reticular. Collagen being strong like rope, elastic thinner like elastic bands but branching, and reticular a web, but very thin and fragile. Alright, so I've put numbers here next to the major groupings to give you an idea of how many you find in each one. So the first one, we have 6, and it's broken into 2. Cartilage is 3, bone 2, and blood 1. So let's start from the easy and go to the hard. Right, so blood has, blood. So it's the only liquid tissue. So what's its matrix? Well, you've got blood basically breaks into, and we'll see this later on in the course, formed elements and plasma. The plasma being the liquid phase. Formed elements are red blood cells, white blood cells, platelets. These produce a matrix, which is the plasma. So fluid, remember gooey fluid, the thinner the matrix, the more fluid it is, and the very thin becomes the plasma of the blood. So the cells producing a fluid outside them, creating blood. Bone, we have 2 types of bone. We have compact bone, which we focus on at this stage. And then we also have spongy bone, also known as cancellous bone, but we'll focus on it as spongy. So the compact one is the one that we need to learn to recognize under the microscope, but it's fairly easy because it looks like you've just cut a tree down and you're looking at the tree stump. Alright, so that's blood, bone, compact and spongy, and that's the one we focus on. Cartilage, we have 3. So we have hyaline, we have fibrous, and we have elastic. Right, so hyaline kind of means milky. So it's got like a milky, whitish sheen to it. So if you look under the microscope at hyaline cartilage, you're going to see, looks like a pair of eyes staring at you, because you get two cells quite close together. Now, these cells, like all the other cells we've talked about, produce a matrix. And this matrix is really just goo, and it happens to be chondroitin and glucosamine are the main components of it, but it makes this shiny, clear material around the cells, and that's essentially what the cartilage is. Now, going back to the compact bone, it looks like that tree stump. The matrix there, all these little dots I've drawn in there are cells, and the cells produce collagen, and the collagen builds up and gets really, really tightly packed. So if we look at that this way round, so here's all the cells, like that, you've got collagen fibers really tightly packed all the way down. And then once you add calcium phosphate to that, that's what makes it rigid and hard. So it's basically a combination of the tough but flexible collagen fibers with calcium phosphate mineral attaching to it, creating this really, really hard structure that we know as bone. So with the cartilages, all of them have cells producing gooey matrix. Now in hyaline cartilage, which covers our joints, and sometimes referred to as articular cartilage, it's just a clear gooey matrix all the way around the cells, creating this really, really white sheen. Now, if any of you eat chicken legs, and you peel the meat off and around the leg bones, at the ends of the leg bones you'll notice it's really, really white and creamy, and that is the cartilage I'm talking about. So next we have fibrous. And again, fibrous does the same as the hyaline. So it produces a matrix of goo all around it. But this time it also produces collagen fibers in that goo. And that makes it much, much tougher, because now you're adding this really, really strong rope-like material into that gooey matrix. So the cells that are producing this are being linked together, and that makes it really, really, really tough, almost like a rubbery kind of tough. And so you find fibrous cartilage sitting in between the vertebrae. And we call them discs. But they're able to take a lot of stress on them because of all those collagen fibers in the matrix. Our last of the three cartilage is the elastic, and of course, just like the other two, it's got its little eye-like cells. Remember, these are cells, and they're producing the matrix just like all the others. So if it was just that, it would be hyaline, so of course it's got something else in it, which isn't going to be collagen, but I think the giveaway is the fact it's called elastic. And so there's lots of elastic fibers running in it. And when you see a good slide of elastic fibre, you can't, it looks like hyaline except for it's got all these dirty lines through it, so these dark lines running through it, and that's the elastic fibres. So elastic fibres here, collagen fibres here, separate them from the hyaline, which is just the goo. Fibrous is goo plus collagen fibres, elastic is goo plus elastic fibres. That's the simplest way to think of these things. So now we've covered blood, which is red blood cells and white blood cells producing a liquid matrix, which is the plasma. We've got bone, we've got compact bone, which is cells in circular formation which produce collagen fibres which are tightly packed, which have calcium phosphate added to them, which makes it hard. We've got spongy, which has lots of spaces in it and allows for other types of process like the formation of blood, for example, which we're not focusing on at this level. And then we've got the cartilage, three types. Hyaline cells, cells tend to group together as twos and look like eyes because of the nuclei, looking like the pupils, but it produces this gooey matrix, the chondroitin glucosamine matrix, and it's nice and clear in hyaline, makes a very, very smooth surface, very, very low friction, and that's good for joints. Fibrous has collagen fibres produced by the cells and pushed out into the matrix. That makes it really, really tough, rubbery tough, and that's good for taking the weight of the upper body on the vertebral discs. And then the elastic, I never said what the elastic was for. Well, the most obvious one is the ear. And I'm sure many of you, when you were younger, had siblings, and there was always that rather irritating sibling that liked to grab your ear and bend it almost off. But of course the ear, once you bend it, fortunately, because of the elastic cartilage, returns to its original shape. So that's those three. So that leaves the connective tissue proper. Now, connective tissue proper, as I said, is broken into two groups, which makes it a little easier for us. So let's consider the two groups first. So connective tissue proper loose and connective tissue proper dense. There are three in each, so in loose we have areolar, adipose and reticular. Now, adipo equals fat. These are the cells that store our fat in our bodies, which, if you're like me, you wish you didn't have quite as many of them as I happen to have. But these cells are quite easily spotted because they're large, they're white inside because they're full of the fat, and they've got the nucleus pushed off to the side because this is all fat in here. Areola, if you look at it under a slide, it just looks like a complete and utter, it's like spaghetti on a plate with gaps in it, because you've got cell types in here, fibrous cells, and they're producing all three types of the fibres in the matrix as well as the goo, and you're going to have white blood cells in there and lots of other things going on. And this is a very good space filler because of all those collagen and elastic fibres that goes in, and it holds different parts of the tissues just together and holds everything in place and allows cells to attach to it. And as we said before with reticular, connective tissue proper loose reticular just creates this wonderful spider's web network for everything to attach onto. And this is all because it's mostly reticular fibres which are being produced by the cell types. And these are all fibre cells because that's what they're producing, the three types of fibre. This one produces all, this one produces reticular, and this one, although it's supposed to be a fibre cell, it's really just storing the fat. Right, dense. Dense, we can have dense regular and dense irregular. I'll do those two first. And regular, well, dense regular produces collagen fibres and they all line up like that. So it's like rope. The examples of this would be your ligaments, which join bone to bone, and also your tendons, which join muscle to bone. So B to B, bone to bone, M to B, muscle to bone. They all lie in the same plane, therefore they're very, very strong in one axis. Irregular. Irregular, very, very close to regular, because many of them are lying like that, but you've got some lying in planes like that as well. This is very, very good for holding things, like anchoring things all the way around. So you find this in the dermis of the skin, and it actually holds the epithelia, the epidermis, down onto the lower structures extremely well. Just a minute. And our last group is elastic. And so it's got collagen fibers in it. However, it also has elastic fibers. So it's strong, but it's also got that ability to be stretched and to return. So it's got collagen and elastic fibers in it. It's this type here which tends to give us our stretch marks because of the elastic nature. The elastic area gets, and you know, a rather poor but accurate example would be underwear. Men in particular tend to wear underwear for many, many, many years, and the elastic eventually starts getting pretty sad and tired and not really working anymore. And so it's been overstretched so many times, and eventually it doesn't really come back to itself anymore, and it crinkles up. That's exactly what happens to the fibers, the elastic fibers in the collagen. So it gets overstretched for too long, and so when it's let go, instead of coming back to its original, it actually kind of just bunches up and creates those kind of like funny little bumps that you notice in a stretch mark. The most common way, obviously, to get stretch marks is during pregnancy, because of course the growth in the abdomen of the pregnant lady at that time is rapid, and so the area is being stretched very quickly, and so that's an obvious way of getting them. But also during our pubertal years, all of us grow at some point very, very quickly, and so most people, if you actually took the time to do a survey, you'd find that they have stretch marks in and around their upper thighs in particular, just where the body is suddenly taken on a growth spurt and again has been overstretched past or beyond the ability of the connective tissue to keep up with it. Alright, so connective tissue proper loose, areola, connective tissue proper loose, adipose, connective tissue proper loose, reticular. Connective tissue proper dense, regular, connective tissue proper dense, irregular, and connective tissue proper dense, elastic. These are our CT proper, connective tissue proper, these are our actual connective tissues. Alright, so that's our connective tissues. These are the ones that we need to know about and look under the microscope and look at. We haven't talked too much about their various roles and functions, etc., but that's enough for us to get started with. But the important thing is to remember that these connective tissue cells produce a matrix which is inside the cell and pushed outside of the cell. Much of it is goo, but it also contains these fibers. And so in the connective tissue proper side, these are fiber cells producing these types of fibers, and depending on the level of fibers they're producing will give them their particular function. Alright.